Hi, this one we're going to dive a little bit deeper in this temperature specific volume. So I will start to draw our TV diagram. We have this dome shape divided into three different regions: compressed liquid, saturated liquid vapor mix, and superheated vapor. Then we have this constant pressure line that's going like that, right? This P is a constant. Okay, and earlier we also talking about at this constant pressure line, this temperature or this boiling temperature is called a Tsat at this particular pressure. Now we're going to look at a little bit deeper. So how about at this point, if you look down, that's going to be our specific volume, which is meter cube per kilogram. If it's a English, it's going to be pound mass per cubic foot. Then, so that's our specific volume. We're going to call this VF. And what does VF stand for? Which means, of course, it's a specific volume at what? Saturated liquid. Because saturated liquid is when the liquid starts to become vapor. You know, the first tiny little droplet of liquid start to become vapor. That's saturated liquid. Then we continue to increase the temperature. The quality here is equal to 0, and the quality increases, going up, going this direction, until here it's completely vapor. Therefore, saturated vapor. Therefore, the quality X is equal to 1. So during that process, and how about here? At that point, I better probably use a dash line. So, whoops. It's all right. We can figure this out. Okay. So at this point, we're going to, this is X equal to 1. That's going to be our called Vg when it's touching the saturated vapor. Vg, that means it's specific volume at saturated vapor. With saturated vapor, and that's the specific volume, Vf, and that's Vg. Of course, by looking at this, we know saturated liquid, by common sense, is going to be way less than Vg, right? Because gas is going to take up way much more volume than liquid. So Vf is less than Vg. Okay? And we're going to continue to add heat to it, and you realize the temperature go up above saturated temperature, and also our V specific volume going to be even greater than Vg. So here I'm gonna generalize some rule here, and that will gonna help us tremendously in thermodynamics to figure out in the future, define which phase it is. Is that superheated vapor? Is that compressed liquid? Or is it saturated liquid vapor mixture? Or is it saturated liquid only? Or is it saturated vapor only? So here are the rules. So we're going to look at this. How about maybe we look at the table? If it's in region 1, which is we call compressed liquid, right? If it's at compressed liquid, what happened to be our temperature? What happened to our specific volume? We know the temperature is going to be less than saturated temperature. For example, the water you take out of a sink at 1 atmosphere pressure, it's for sure less than 100 degrees Celsius, right, normally. And then that's going to be compressed liquid. And what's the specific volume characteristic? This V here, during this time, what happened to the V? Look at the x-axis. It's less than our Vf. So if the V specific volume is less than Vf, less than specific volume at saturated liquid, we know it's going to be compressed liquid, right? Now we're going to looking at another phase, which is our saturated, liquid, and vapor mixture. Mix. In that situation, what do we know about the temperature at that time? Regardless, while you're adding heat to it, the temperature, however, stays at that boiling temperature, staying as that saturated temperature. So T is equal to T sat. What happened to the volume during this time in the dome 2? This V is between where? Between VF and VG, right? Here's a little note. If V is equal to VF, then we know it's just saturated liquid only. If our V is equal to VG, specific volume is that, we know that's going to be saturated vapor. Otherwise, if it's in between those two values, we know it's a mixture. Another way we know it's a mixture for this special case is, I'm going to add for this, the quality. If the quality is between, if there's a quality between 0 and 1, I mean quality is in range of 0 and 1. If there's a quality, we know it is what? A mixture. Okay, now let's look at the third one. If this is going to be superheated vapor, as superheated vapor, as we already know, the temperature going to continue increase. I'm going to use this color, and it's going to be even greater than saturated temperature. If it's greater than 100 degrees Celsius and it's at 1 atmospheric pressure, we know it's going to be superheated vapor. And how about V? The V is going to be even greater than Vg. Then we know it's a superheated vapor, right? And let me ask you, what's the superheated vapor quality? Not available. How about what's the quality for compressed liquid? Not available. Because there's not even superheated liquid or there's no saturated liquid nor saturated vapor, so it's not available. Quality is only, it's exclusive just for saturated liquid and vapor mixture. Okay, so that will help us in the future to determine what phase it is in. All right, I'll see you next time. Bye.